I welcome you to the online MOOC course of software engineering. Today we are looking on the topic extreme programming. So the contents of today's lecture is going to be XP genesis, practices, customer collaboration, core values, team dynamics, followed by quality and metrics. So first we will look into what we mean by extreme programming. So basically extreme programming is going to be an agile software development methodology which is more concentrating on customer satisfaction, continuous feedback, rapid iteration. So the main focus is with respect to how the customer is going to get satisfied with the development process. We will be getting continuous feedback from the customer such that it moves from the project start to the end, and the rapid iteration in the software development is going to give procedural or incremental updates to the people such that it is going to provide a very good software delivery. It is created by Kent Beck in late 1990s, and it is mainly to handle the changing requirements and to reduce the project risk through disciplined engineering practices. So unlike traditional models that we have learnt in the prior classes, we would use something called as changing requirements in extreme programming. So changing requirements is going to be the requirements that could change over a period of time from the start of the project. In between also you may change the requirements or update the requirements, which is not going to be possible in traditional software development methodologies. So we will look into the history and evolution of the programming. First, in 1996, through the Siler's C3 project, payroll project, this XP emerged into practice. Later, Ken Beck, as we have seen earlier, he tried to provide a new framework which has good practices. In specific, it introduced 5 core values and 12 supporting practices, which is trying to have a very good impact in the software development industry. Followed in 2001, the Agile Manifesto was invented, which is going to be influenced through these practices, where Scrum, DevOps and modern CI/CD practices were taken care. So here we will try to understand why we have to choose extreme programming. So the first and foremost, it is with respect to team and environment. So to be specific, XP is more suitable to a team of limited size, where you will have very limited number of people and the involvement with the customer, the client who has given you the project, is more. So we have the concept of online customer, where the people who are directly the stakeholders of the project will come to the premises and they will be giving the input directly to the developers. So the environment will be in such a fashion that the customer availability will be very high. The project characteristics that are suitable for extreme programming are with volatile requirements. So what we mean by volatile here is the requirements might change at any point of time. We are not having rigid requirements as like our traditional waterfall models. Here there is a concept of volatile requirements, and where we need tight deadlines. So when you want people to provide the solution at a very short time, XP could be a very good choice. Followed by the cost of defects. So when there is any issues in the software that is being developed, in any modules of the software, if the cost of that defect is going to be very high, then also we can choose XP. Okay. Basically, XP is chosen by startup companies and greenfield projects. The technical feasibility is also important, because when we say about a team with all these project characteristics, there should also be a facility for automated testing. So, only if we have some technical feasibility, we could choose XP as the software development methodology. So, here we will just try to understand the main difference between the traditional waterfall model and the extreme programming in this slide. So, here I will just go through the problems with respect to the waterfall model. So, in waterfall model, we have sequential phases. Mainly it starts from requirements, design, implementation, testing and maintenance. And we might have understood that this sequential phases has to be done in the specific order. You cannot move between the phases. And the very important thing with respect to the traditional waterfall model is that only when you freeze a particular phase, you can move on to the next phase. So, what I mean here is, only if we have completed the requirements phase, you can move to the design phase. Similarly, once we have completed the design phase, we can go back to coding or implementation, and once the implementation is done, we can go for testing, and once the testing is done, we go for the maintenance. This phase is sequential and also it is fixed. Okay. And each and every phase, there is a lot of documentation that we have to do. Okay. And the third point that is mentioned here is, testing is only done at the final phase. So, if there is any defects at the early phases, that will not be checked until the final phase has reached. So, that is one major problem with respect to the traditional waterfall model. And as we have already discussed, if the cost of defects is going to be very high, this model will fail, because we test only at the final phase of the project. And another important issue, another major drawback with respect to the waterfall model is that we resist late changes. So, changes here is change in requirements. So, basically when a user or the client is going to provide you the requirements, that requirements may change at a period of time, and that time is restricted only till your requirement analysis phase. In extreme programming, as we have said here, there is a iteration cycle of 1 to 2 weeks. So, this iteration can be introduced with changes. So, if I have the first iteration is having some requirements. This requirements could be added with a change or update, and that could be given to the second iteration. Okay. So, the iteration is going to be one single work, and that work will constitute 1 to 2 weeks. The second important thing is that we have something called as face-to-face conversation. So, face-to-face conversation here says about the interaction between the developers and the client who has given the project. Sometimes it is also within the team of developers. So, here I am just trying to say as developers, because there is no distinction in the people who are going to work as requirement analysts or designers or coders. Everybody are going to be developers, where they will be involved in all the type of activities in the software development life cycle. And the third point here, it says that it is going to have continuous testing and verification. After each and every iteration, there is going to be a testing phase and a verification phase. So, once a iteration is being developed, if it has been completed, we will be trying to provide a working software. Sometimes we also call that as prototype or a simple working software. Okay. So, this simple program will be tested and will be verified to check the validity of the developed work. So, as and when the iteration goes on, we are trying to increase the change in requirements. So, obviously extreme programming embraces changing requirements. So, this is going to be the key differences between the traditional waterfall model and the extreme programming. The main difference is that here in waterfall we have sequential phases and we have rigid phases, as we have discussed. It is going to be requirement analysis followed by design, implementation, testing, and they are freezed. You can only go to design phase if we have completed the requirement analysis phase, and you can go to implementation only if you have completed the design, and you can go for testing only if you have completed the implementation. So, only after the entire project is being completed, you go for the testing phase, and if there is any error, you have to reiterate the first three phases, which is going to be very complex and it is also very costly. So, this problems are being addressed through your extreme programming, where we will be having short iterations and each iteration is going to have all these phases. So, you do requirement analysis, design, implementation, test, that small prototype. Then we go on for the second iteration, add new requirements, repeat the cycle, so that if there is any problem with respect to your prototype, that defects are being understood and they will be rectified at a very short time and also at a very low cost. So, with respect to extreme programming, there are 5 core values. So, we will be looking at one by one. So, the first is going to be communication. So, here communication is going to be treated as a very important aspect in extreme programming, and it is mainly treated as the risk reducer. So, the communication, as we have introduced, it is going to be with respect to developer and the client and also between developers. Okay. So, developer and client, they will be sharing something called as user stories that we will be seeing in the further slides, and developer will be doing something called as pair programming, which is very important aspects with respect to this XP. So, here we have something called as daily stand-ups, pair programming and collective code ownership. So, daily stand-ups are going to be the meeting that will be involved within the team, where all the developers, all the software engineers will join in a team, which is going to be mostly informal. They will try to understand what is going to be the user story, and for that they will be trying to provide a solution and they will try to code in that corresponding day. So, it is going to be one day work. So, that will be understood, or that will be discussed in a meeting which we called as daily stand up meeting. Next, when they work, they prefer something called as pair programming. So, this pair programming, as the name indicate, it is going to be a programming that is done in 2-member team. So, normally this 2-member is constituted by a senior, junior, or an experienced and a fresher, something like that. Why? Because it also influences knowledge transfer and also commitment between the members of the team, and the members are going to be deferred each and every day, so that there will be a continuous communication across the group, and they will be having respect between each other, and also they will be trying to be ease for support. Okay. And the main third point with respect to communication is that they have collective code ownership. So, the major issue in a software engineering organization is that if a team works on a project and they have completed, that entire work will be with respect to one single team or the person who have worked in that corresponding team. So, this will not be a good infrastructure. So, they have something called as collective code ownership, where each and every one in the team is responsible for doing any sort of additions or deletions or updations. So, it is having a collective code ownership, so that we ensure knowledge flows instantly and there is no silos. So, there is no walls or any barriers between the teams or between the people working in that corresponding organization, and it will also remove the duplicate works and some integration surprises. So, mainly the daily stand-ups is to align with the team and progress with respect to the work that has been discussed. And pair programming, so as I have discussed, this is going to be a real time knowledge sharing, and it also provides instant code review. So, as one of the programmer is going to be experienced, whatever new thing that has been introduced will have a code review at a minimal time. So, that is the main aspect of pair programming, followed by collective ownership. So, it is important that everyone is responsible for the entire code base, and it is trying to break down the knowledge silos. So, there is no barrier between the code ownership. So, everybody within the company is going to have the responsibility of the code. So, the second core value is simplicity. So, in XP, the main thing what they have introduced is that 1 to 2 weeks of iterations. So, within 1 to 2 week of iteration, they are trying to provide a simple possible work. So, that will try to produce a minimal cognitive load, and it accelerates delivery and leaves design room for tomorrow's certain changes. So, the main aspect of simplicity is that you try to do something for today. So, whatever you can expect to complete within that corresponding day, on a stand-up meeting they will be trying to do the progress and they will try to code. And there is a concept called as refactoring. So, refactoring is changing the code which is available to augment the new functionality. Thereby we are trying to update the existing code and trying to delete the dead code if necessary. And since it is going to be very simple, the cognitive load with respect to the work is minimized. So, the code is trying to be very easier to understand, test and maintain, so that we will try to provide a sustainable development. So, the third core value is going to be feedback loops. So, here the feedback mainly is from the fellow developers or through the clients. The feedback loops are very short, such that it could be from seconds to months, not more than that. So, at each and every level, when there is a defects or if there is any assumptions or any guides, you will be trying to get the feedback. So, from the unit test. So, what we mean by unit test? Once a particular module has been completed, we will try to understand whether that is working fine or not. So, there is going to be a small verification for the unit test, okay, for the unit that has been developed. So, that feedback you can get within minutes. Since we do something called as pair programming, you can also have pair reviews during this unit testing, where we can find instant feedbacks within seconds, since we have a experienced hand in one of the pair in pair programming. When you give customer demos, once a particular prototype or particular module has been completed, we do something called as validation, where you check the module with the customer or the client. So, you can have validation for each and every iteration, and once the validation is complete and you have gone through one release of the software, there is something called as production metrics, where we can learn from each and every release. Okay. So, here through pair programming, unit testing, stand up meeting, pair negotiation, acceptance plan and iteration plan, for each and every steps we will be getting the feedbacks, which is going to provide much clearer aspects with respect to the move forward in the next iterations. So, fourth one is courage. So, here we will be trying to deploy the unfinished code daily with respect to the stand up meeting that has been done in the initial day, and if there is any issues, if that day is not proper, it is okay, because it is going to be one day work and you can throw that and move forward the next day. But if you have done a very big code for say months, and if it is going to be, if it is not as per the requirement, we have lost a month's work. Okay. So, we do have courage to understand that the software is that we have developed is strong and we can throw it out without any issue. Okay. And we can have the understanding that this will not work, and you can take that as a feedback again. The fifth core value is going to be respect. So, this is going to be with respect to the fellow developers who should have the reasoning with respect to the refactoring that we do. Okay. And the main important thing with respect to respect here is that in a normal software organization, we have conflicts between the developers and testers. Why? Because if you are trying to say there is a bug in a particular module, the developers will not be having a positive sense with respect to that bug, right. But here, through respect, since they have attended the stand up meeting, pair programming, pair reviews and all, they do have mutual trust between the developers and the other seniors. So, they will accept the critics without any defense. Okay. and this is what is the 5 core values of extreme programming, followed by the practices. We have 12 practices in XP, starting with the planning game, planning. So, this is going to be the first practice of XP, which is called as the planning game. A planning game is going to be the collaborative negotiation where the customers and the developers, they jointly try to work on the project. So, it is actually something like a business and the technology working as a team. So, business is with respect to the customer and the technology is with respect to the developers. So, the planning game starts with the user stories. So, we call this as user stories. So, user stories are usually paragraph sized. So, say for example 4 to 5 sentences. So, which will describe what they require as a customer. Okay. And once the stories has been taken, the developers will try to analyze the customer stories and they will try to provide a minimal design. Okay. So, they will try to find whether this could be done with a effort. Effort is going to be the time taken with respect to this one iteration. Okay. So, whatever work they are trying to do, they have to complete within one iteration, or you can go for multiple iteration if necessary. Okay. And based on the design that is being given by the developer, both customer and the developer, they jointly prioritize to follow which user stories has to be executed in which order. Okay. And they do commit for an iteration because there could be several user stories and it could not be done with one iteration, so that they can move for several set of iterations. Okay. So, the planning game goes like, we receive a user story. It is not one story, you can have multiple user stories, and once the user stories have been received, the developers will try to estimate the effort and they jointly prioritize and commit to a iteration. So, basically the user stories are being taken and they have two phases here. One is exploration and second is going to be iteration. Okay. So, exploration is where the user is not having that much knowledge with respect to what they actually need. So, they go to the exploration phase and then once they get influenced with the project, they go to the iteration where the user stories are proper. Okay. Once we receive the user stories, we try to go for iteration where we have something called as pair programming. Okay. So, pair programming is going to be the methodology where you will be having 2 or more people within the software development, and one would be experienced and one would be a novice developer. And here again we have something called as development and testing. Okay. So, both development and testing will be happening at the same time. Okay. And they will be trying to do a collective code work base where each and every iteration is trying to provide a development a code, and that will be adapted or that will be saved in the collective code base. And it could also have something called as test, which will be done for each and every iteration, and this is going to be a loop. Okay. So, as we have discussed in the second point, the user stories will be taken and it will be analyzed and produce a design. Okay. That process is being shown here. So, we have user stories followed by we have an iteration, a set of iteration where a pair programming is being taken, which has both development and testing, and each and every iteration will produce a particular code and that will be saved to the collective code base, and this collective code base will be tested and again it goes on through a iteration. Okay. So, once all the iteration has been done, you will be getting a very good prototype or a software which will be given to acceptance test. Okay. So, this acceptance test will be taken by the customer, and once if it passes, it goes for release, or otherwise we have to go back to the iteration. Okay. So, next is going to be the small releases strategy, where we are trying to build each iteration as a very small unit of work. Okay. So, since it is going to be small release, it is a smallest marketable feature and it enables A/B experiments, rapid experiments and course correction, and also minimizes sunk cost of flawed features. Metaphor as an architecture. So, metaphors are going to be the analogies that could be used for defining the naming, module boundaries, design decisions and replacing exhaustive upfront architecture documents. Okay. So, say for example, as a metaphor, say for example, if we are trying to design an e-commerce application, a shopping mall could be taken as a metaphor, as an example to shape the concepts like how the storefront could be, how the catalog should be, how the checkout should be. So, metaphor is actually an analogy that could be used to set the boundaries, naming and other design decisions. So, the rules of simple design is that all the code that we have, it should be having incremental work, it should pass all the tests, it should express every idea that we need to express, and there should not be any duplication, and it should minimize the number of classes and methods, majorly the code. So, it is trying to say that we have to be very simple with respect to the design that we have to give for the software user stories. Followed by testing, here we have a new principle which we call it as test driven development, TDD for short. So, here we have, it is actually a cycle that creates comprehensive regression suite and it forces modular design and produce living documentation. So, what happens is that once the user stories has been given, we start the testing process. So, we try to do the test cases. So, first one is writing the test cases, and if we need, you can also refactor. So, as we have understood, refactor is going to be minimal change that we introduced in a module which is not going to have any problem later on. Okay. So, refactor, and after refactoring we write the code. Okay. So, write a test case, refactor what we have already and then write code. So, this is going to happen at the cycle. So, this is what we call it as test driven development. So, refactoring, as we have just discussed, it is not a backlog item, it is a habit that is performed every few minutes to keep the code easy to change. Okay. So, it is something like you can just replace a magic number here, say for example, if you have n is equal to 10, just change to some other number and check whether the code is working or not. okay, or just introduce a new parameter object and find whether your software is working good or not. So, refactoring is a change that is introduced in the code and that is not going to have any impact later on. So, the next thing is pair programming mechanics. So, pair programming will be having two main people as we have discussed. One we call it as driver, the no voice or the less experienced person, the developer, and the navigator who is going to be the experienced person who is going to help the driver work perfectly. So, the main characteristics of the driver is he writes the code, he focuses on the tactical aspects of the syntax and implementation. So, main thing is he writes the code, he does the implementation, whereas the navigator, he reviews the design, he thinks ahead and catches defects, okay, which provides and also provides strategic direction. So, navigator is going to be the experienced person who is going to help the driver to work in a better fashion. The collective code work ownership here says about anyone within the team can improve the module anytime. So, it is not going to be with respect to one single person of the team, it is widespread across, okay. So, anybody can change. So, this is going to provide distributed expertise and also accelerate onboarding of new team members. So, when there is no expert is available, it is that everybody in the team knows what happens in the code, so that there is no need of an expert for doing a particular job. Continuous integration. So, each and every iteration is going to do a particular job, but we have to make sure that job gets integrated to the main chunk and at least once in a particular session. So, this continuous integration is very, very important, because if it gets integrated to the main trunk, then only the work is going to have some meaning, okay. And once if there is any problem with the integration, probably we have to do some changes within minutes, because it is going to be a very simple problem that has been completed in a particular day. So, it is not going to be very big to refactor. So, on-site customer. So, again, so since the customer is already available in the premises, we have instant feedback from the customer, and we also have acceptance testing, where the acceptance criteria could be clarified at a very easy fashion, okay. So, this is an anatomy of a user story, a very example. So, a user story could be as simple as that. So, as a type of user, so say for example, as a customer, I can do purchase a product so that I can reduce the time. So, something like that. So, it is main important aspect is that what is the type of user, what kind of action you want to do with the application and for what, okay. So, at the back of the card you have something called as the acceptance criteria. So, once you get the user story, the developers will try to find a metaphor and get a design, okay. So, the acceptance test criteria is trying to say what is the necessities that you need to approve this software being developed. So, followed by the last one, the coding standards. So, whenever you try to code, there is a necessity to follow the certain coding standards. So, what all things we have to standardize is that we should go for a good formatting, naming conventions and also the code structure, okay. So, you have to have modularity within the code, and how we can enforce these standards is that we can have a return standards and followed by any checkpoints. So, here is the velocity tracking. So, from here what we can understand is that, so this is going to be the days. So, here if today is 6, we have already completed 5 days and we have still some more days pending, and these are going to be the modules that we have completed, and we have forecasted we can complete at say 15th day. Okay, and if the forecast is going to be high, very high, you can also complete more modules. If it is forecast is low, we are at a little slower pace. Okay, so this is trying to understand how much days we would need to complete the work. And defects management, as we have said, since it is very small iteration, the defects could be identified and cleared at a very easier pace when compared to the normal traditional waterfall like approaches. So you can fix them immediately through pair programming when we do pair reviews, and it is very simple when you compare if it is found in production. So this is trying to say the scrum of pairs. So distributed pair programming is another aspects where the pair programming could be happening at different place, at remote teams. So they can join through some of the IDEs, collaborative IDEs, and they should have a time zone overlap, and if necessary we can also use fair pairing such that the distributed pair programming influences the software development things. So what are the things we have to avoid? What are the keys to success? So skipping the test or keeping slowed ownership is the problem, and allowing unsustainable overtime, absent or unpowered customer management dictating estimates. So if you have these kind of environment, XP will not have good effects. Okay, but when you have embracing all practices together, each and every person is committed to work, and secure management support, investment in coaching and training, and if you can foster the culture of trust and learning, then XP is going to be a good methodology for software development. So if as a student, if you want to go for XP, you can install some IDs, identify a particular program and identify a problem, write user stories, go for some iterations, and try to provide demo to a person, anybody who needs, and then go for a retrospect. So in summary, we have looked into the XP genesis, how it came into practice, how it is involved in agile methodologies, and we have understood 5 core values and 12 supporting practices, which all includes this customer collaboration, core values and team dynamics, and followed by the metrics. Okay, so this is about extreme programming. So we'll see in the next class. Thank you.